So what I'm going to do is call out just a few, there's quite a bit more than this, but just a few of the well-known unique addresses. That is networks that fall outside the zone that you probably shouldn't use or probably should use according to what your use case is. So the first thing that jumps out here is the 10.0.0.0 network. Another one is the 172.16.0.0 network and the 192.168.0.0 network. All of these ranges right here, and notice that this range right here is actually much larger than its classful range. So we have 256 networks within this. So with this, these unique addresses, these are private addressing, and private addressing means that it's assigned to a business or a home, but it could be assigned to lots of different homes or lots of different businesses, or it's not something that's routable on the internet. It's not something that's routable out there in the world. And so it is only supposed to be within the private network. And then once it exits that private network, then it needs to be translated into something else, and it needs to be translated into a public address. So then next we have the 0.0.0.0 range, and that represents everything essentially. That's the first network address, and so that represents, well, if this was a 0, then this would represent all of the network. But for this purpose right here, just don't use this range. This is not a range that's going to be assignable. Then we've got this 127.0.0.0 address right here. This is what's known as a loopback address, or it's actually a range of loopback addresses. We'll talk about that in a second. But this one is reserved for loopback addresses, so that way we can test our NIC cards and our interfaces. And then we have this 169.254.0.0. If you plug your switch into a network but does not get a dynamically assigned IP address to it, but it's looking for a dynamically assigned IP address, what it will do is it can't find an IP, a DHCP server, and so it will then just take on one of the addresses within this 169.254 addresses. So you typically wouldn't assign your machines to this address range. This would be reserved more for networks that wouldn't have a DHCP server on it, or if you need to connect to certain pieces of equipment that are not picking up a DHCP address, then possibly you can connect into that equipment using this address right here. So when we get into routers, what happens is that we can have a bunch of networks that can get summarized up into one network. And so it will condense things down into some summary networks. But the whole internet can be condensed down or summarized into one address. And that's what you're looking at right here. This represents the whole address. This represents a summary of all of the networks that are out there. So this is a summary address for everything. And we see this used quite often in things like access control lists, where you're trying to block certain traffic or allow certain traffic, then we would use this. Or another example, it would be like a routing table, and this would represent the default route that I'm trying to, if I don't know where it goes, then the last resort, let's send it in this direction and get it to the next hop. And so this address right here, 0.0.0.0/0, represents everything, all of the internet. What we'll have on machines is what's called a loopback address. And the loopback address is used for testing that interface. So here I have a machine. It has a network interface. And that network interface, let's say it's not plugged into the network right now. If I were trying to ping the loopback address, because that interface is down, it's not going to communicate. Nothing is going to happen. And then let's say now we plug it into the wall or into a network connection, and that interface comes up. There are certain protocols and certain things that are activated on that interface, and now I can ping that loopback address, the interface. And what it essentially does is, as that machine, it will test out the stack and it'll test everything out to see if it's functioning correctly. That machine will actually form a packet and send to itself and get a reply back. And then you get a verification that the network interface is up and is functioning. And if you are having additional communication issues getting out to the outside world or to someplace out there, then you at least know that the interface is functioning to a certain level and is communicating at a certain level. So it's used for one of the things it's used for. It can be used for many different things, but one of the things it's used for is to troubleshoot to see if the internet or if your connection, that device is the problem, or if the problem exists somewhere beyond that device. And so loopback addresses can be really helpful for troubleshooting. So there's actually a huge amount of addresses that are assigned to this loopback address, or a whole network. And that network is 127.0.0.0/8. And so anything that 127.whatever, with the exception of 127.0.0.0, that specifically is a network address, so that's not going to work. But any other combination within this, if you get on a Windows machine and ping 127.54.31.68. something, that will actually get some sort of reply, and that's one of the loopback addresses that it's going to be, that you can use for testing that interface or talking to itself. If there's some sort of connection that it needs to make to itself, you can use something within this address range to make a connection to itself. So that is this range right here is devoted for computers and servers, for them to make connections to themselves and test things out. And this is for local traffic on that machine. Now, the one that we typically use as the loopback address to test out that local machine is the 127.0.0.1. This is known as the localhost. In fact, if you ping localhost, it will translate it to this IP address and then ping that IP address. So localhost is just a host. It's within the host file of the machine, and it's just a way to address the machine itself using a name rather than an IP address. But what it's going to do is it's going to translate that name to this IP address, 127.0.0.1. So private addresses are arranged here, the 10, the 172, and the 192. There's certain networks within those that can be used on your local network. So it could be used in your home office, it could be used in a business. So these are assigned to businesses, they're not assigned, they're unassigned. Anybody can use them. You can put them on all of your equipment and use it within your networks for testing or for just communication within your networks. But these private address ranges cannot be used out on the internet. They will get blocked out on the internet at some point. And so as you exit your interface, or when you exit your network, that will get translated into some sort of public address. So these address ranges are not to be used on the internet and out in the public realm. They'll get translated as they exit. So these are ranges that you can use, and they're most often used, in fact, in nowadays. So if you go and look on your computer at home, it will probably use actually even more specific. It'll probably be somewhere in the 192.168 range, and that third octet would actually probably be a 0 or 1. I've seen some exceptions to that, but for the most part, that's the range that gets assigned to your home networks and to a lot of businesses that are small businesses. Then we have that link local network, or link local address. It also goes by a couple different names. We've got the APIPA address, or the automatic private IP address, APIPA, or it's also known as the auto IP. Now, when you connect to a network that doesn't have a DHCP server, but your computer is out there searching for a DHCP server, it's going to look for a little while, and when it fails, then it will say, okay, I can't connect via this method can't get an IP address that's going to be in the range of this network. So I'm just going to take a 169.254.something and it will randomly choose these last two octets. It will randomly choose a number and assign it to the computer. And that way, devices that go through this process, what it'll do is at least it will have some number assigned to it. And what that will do is it'll help make that machine addressable in some way. So let me give you an example of this. As I was going around setting up a lot of card readers, certain readers at these different stations, and the machines themselves weren't on the network, but they were connecting directly to a machine. So they couldn't get an IP address because they're connected to the network interface on these machines. And so the machines weren't handing out this automatic address to these card readers. And so what had to happen was the machines would come up, they'd look for an address, it would auto-assign one of these APIPA addresses, and then I would have to go and manually set on the machine some sort of address within this range so I could connect to that machine and configure it to be set up to work and be able to connect into this computer. So that's a way to network devices that are on the network that don't have a DHCP server, connect these devices and do some configuration and at least do some sort of communication, even if it's not going to communicate to the outside world. All right, that was just some brief concepts around the IPv4 addresses. So we talked about the IP addresses, networks, hosts, and subnet masks, and how those are formed, address types, different address types, and we talked about some unique networks and addresses. Once again, this is not supposed to be a comprehensive view of IPv4 addresses. We didn't get really in depth into subnetting, but this gives you a general idea for future discussions, and then I'll also have a class based on how to subnet and get much more in depth into IPv4 addresses. Thanks for watching my videos. If you like them, could you hit that like button because it really helps me out.